Hello everyone. Today we will be talking about how to calculate the number of moles or N. So we have three formulae. One is N is equal to W upon M, where W is equal to the given mass, and M is equal to the molecular mass. The second equation we have is N is equal to N upon Na, where N is equal to the number of molecules and Na is Avogadro's number, 6.022 times 10 to the power 23. The third formula we have is N is equal to V upon 22.4, where V is equal to volume and 22.4 is because in 1 mole of any gas is always 22.4 liter. Alright. So it means 22.4 equal to 1 mole. Then V is equal to how much? That means V upon 22.4. So that is the amount of moles. Alright. So now let's practice some questions. Oh wow. Alright. So let's have a question. Calculate number of moles in first one 16 gram of oxygen gas. So over here we have 16 gram, so it means N is equal to W upon M. Since gram is given, the weight is given, so that means, and we know that the molecular mass of O2 is equal to 32 units, unified mass, atomic units. So that means 16 upon 32, because we have two atoms of oxygen, so that's why we have to take 32 over here. So that means 1 upon 2, which is equal to 0.5 moles. Now we have 1.8 gram of glucose. 1.8 gram is the given mass, and the molecular mass of glucose is equal to 180 U. So that means N is equal to 1.8 upon 180. Or we can take 18 times 10 to the power minus 1 upon 180. 10 cancel. We have 10 to the power 1, that means 0.01 moles. The third one is 44.8 liter oxygen gas at NTP. So NTP, or the it is the normal temperature or pressure, or standard temperature and pressure. Alright, so that states that we have the volume as 44.8 liter, and now we do not have to take the mass because it is O2 gas and we have volume. So that means N is equal to V upon 22.4. So that means N is equal to 44.8 upon 22.4. That means equal to 2 moles of oxygen gas. But now let's take an example. We have 48 grams of oxygen gas. The first one, okay, so over here we have to take gram. Since weight is given, we have to take N is equal to W upon M. So that means N is equal to 48 upon 32. 16 3s are 48, 2 over here, equal to 1.5 moles. Alright, so now we have a little tricky bit, a bit of a tricky question. 3.011 times 10 to the power 25 molecules of glucose. Now if we hear glucose, that doesn't mean we immediately take the molecular mass as 180 gram. We don't have to do that in this question. Over here the number of molecules are given. That means we have to take the third formula, N is equal to N upon Na. That means N is equal to 3.011 times 10 to the 25th power upon Avogadro's number. Oh, my bad. Over here this is 1 and this is 2, and this right here is 10 to the power 2. So that means 0.5 times 10 to the power 2, which is equal to 50 moles. Let's take another example. 1.6 kilogram of SO3 gas. Now we have to make sure that it is in gram. So that means 1.6 times 10 to the power 3, which is equal to 1.6 times 1000, which is equal to 1600 1600 gram. Now the weight of SO3 is equal to 32 plus 16 times 3 of oxygen, which is equal to 32 plus 48. 3 plus 4 is 7, 8 plus 2 is 10, 80 gram. So that is the weight over here. This is the molecular mass. So that means N is equal to W upon M. So N is equal to 1600 upon 80, equal to 20 moles. Let's take the 7th question. So 1.12 dm cube, so decimeter cube of CO2 gas. So 1.2 decimeter, that means it is 1.12 liter, as 1 decimeter cube is equal to 1 liter. So we have the volume over here, and so N is equal to V upon 22.4. So N is equal to 1.12 upon 22.4 equal to 112 times 10 to the power minus 2 upon 224 times 10 to the power minus 1, which over here becomes 10 to the power 1. So that means this is 10 to the power minus 1. This is equal to 1 by 2. So that means it is 0.5 times 10 to the power minus 1, which is equal to 0.05 moles. I'll explain this one again since it is a little bit tricky. 1.12 decimeter cube is equal to 1.12 liter. So that is the volume we have. And then we just take, I took it in 10 to the power. So that means 112 upon 22.4 and then times 10 to the power minus 1, which is 0.05 moles. Now let's take 8th question. 3.42 milligram of cane sugar. Now the molecular mass of cane sugar is equal to 342 units, and 3.42 milligram is equal to 3.42 times 10 to the minus 3 gram, which is equal to 123 equal to 0.00342 gram. So we can do this, or we can do 342 times 10 to the power minus 5 gram. This is more easier. So this is the weight, and now we can take n, the number of moles, is equal to 342 times 10 to the power minus 5 upon 342. These two get cancelled. That means 10 to the power minus 5 moles. Let's take the 8th question. Oh, this is the 9th question. I'm so sorry. So 102 cc N2 gas. So 1000 cc, we know that 1000 cc is equal to 1 liter, because 1 cc is 1 times 10 to the minus 3 liter. So that means 112 cc is equal to how many liters? So we cross multiply 112 upon 1000. So that means 0.112. So that means 0.112 liter, or 112 times 10 to the minus 3 liter. So that is the volume. And now the number of moles is equal to 112 times 10 to the minus 3 upon 222.4, which is equal to 224 times 10 to the power minus 1. Minus 1 becomes plus 1, so this is minus 2, and this right here is 0.5 equal to 0.5 times 10 to the power minus 2, which is equal to 0.005 moles. Now let's do the 10th question. And the 11th question is going to be a little bit tricky. So let's do the 10th question first. 6.022 into 10 to the power 20 molecules of N2O. So that means that the number of molecules N is equal to 6.022 into 10 to the power 20, and Avogadro's number is equal to 6.022 into 10 to the power 23. So N is equal to this right here upon Avogadro's number. 20 and 23 cancelled in order to make 10 to the power minus 3. These two get cancelled, which states that 10 to the power minus 3 moles. Now we have 8 AMU of helium. of helium. So 8 atomic mass units of helium. So that means that the weight is equal to so that means 8 AMU. So 1 AMU is equal to 1 upon Na. So that means 8 AMU is equal to 8 upon Na times Na. Oh, I'm so sorry. 8 upon Na is the amount of grams. So we have the weight, given weight, and we know that so weight is equal to 8 upon Na grams, and the molecular mass of helium is equal to 4 units. So that means 8 upon Na divided by 4 equal to the number of moles, which is equal to 2 upon Na moles. So I skipped a few steps over here, so I'll do them over here properly. 8 upon Na upon 4 2s are 8 equal to 2 upon Na. So this was the last question. Thank you.